The pocket wallet was invented in the 17th century. Europe had switched to paper money, and the gents of the day needed a handy way to pocket their cash. There's a slot for everything: credit cards, ID, and of course, cash. And yet these wallets remain slim enough to fit into a trouser pocket. These fine handcrafted pocketbooks are made from high-grade vegetable-tanned leather. An employee selects a hide and arranges it on a work table. Then he chooses a die shape like one of the wallet's inside pockets. Using this hydraulic press, he punches out the part. He cuts 11 different components for the wallet's interior, using a custom die for each one. He chooses tougher leather and a contrasting color for the wallet's exterior. He now measures the thickness of the interior components. Using what's called a skiving machine, he shaves them down to 0.7 of a millimeter. Another worker preheats an embossing machine. It hot stamps a pocket part with the company name and the Royal Warrant logo, which signifies that the Prince of Wales purchases this company's leather goods. Using a different skiving machine, they shave down the edges of the exterior wallet parts. This thinner border will make the parts easier to assemble later. The next worker applies a water-based adhesive to a leather strip. It will reinforce the top of a fabric square. With this manual device, she turns the top edge to fold it in a straight line. This leather-trimmed fabric square will be used to create a credit card pocket. She stamps a thin groove onto the leather trim to give it some definition. Next, she builds a credit card slot with 2 of the squares. Using an awl, she scores a line in the fabric. The line serves as a guide as she stitches the squares together to complete the slot. She layers a third leather-trimmed block of fabric to create a second slot, then adds a leather panel that forms the third credit card slot. She glues and tucks the excess leather over the back of the fabric pocket. Then she checks the alignment of the slots with a tool called a bone folder. The next worker sews the credit card compartment together. There are 2 of these per wallet. They glue both compartments to the wallet's spine, made of fabric and leather. This spine is called the bend section because it bends to fold the wallet in 2. She attaches the bend section to a divider for the money pocket. This divider is a bit longer than the assembled interior components to facilitate the bending action. She glues a lining to the wallet's leather exterior. Here, she uses a special hammer to ensure the interior and exterior components of this wallet adhere well. Then she trims the corner of the rim to make it look neat. She rounds the corners of the wallet to give them a gentler profile. Now she stitches the assembly together, leaving the bill pocket open at the top. The next worker tucks a metal wedge under the rim to protect the rest of the wallet as she trims the rim close to the stitch. Removing these few slivers will make the wallet more flexible. She slides the bone folder into each credit card slot to remove excess glue. Finally, a few dabs of leather preservative, and this luxury wallet is ready for retail with a price tag to match. The only question is, will that be cash or credit? Luxury sailboats evoke thoughts of freedom and sunsets on the ocean. But in the factory, it's all about hard work, because luxury sailboats are still mostly made by hand. Just a few hundred units are produced every year, each boat requiring up to 3,000 hours of work. Sailboats have come a long way since they were first used on the Nile River some 6,000 years ago. These luxury sailboats are designed using computer-aided design software, which allows the engineers to optimize the hull shape for stability and speed before actually building the boat. They build the hull from fiberglass, which comes as knitted fabric, and as mats of random strands pressed together. These two layers are hybridized to form a light but very strong material. Huge molds are used to build the hull of this 45-foot boat. Workers unroll the fiberglass and spray it with resin. Then they unroll the next layer of fiberglass, which overlaps the previous one, making for a very strong construction. The resin hardens as it cures. Boat parts are so large and heavy that they must be moved with cranes. This part is called the transom. It will be attached to the hull with fiberglass while it and the hull are still in the molds, creating what's called a monocoque construction. This hull surface will receive the structural grid, which will support the engine, mast, fuel tank, and water tanks. Meanwhile, carpenters fashion the wood components. This door is made of solid teak, a durable hardwood that doesn't rot. The wood parts are then put into a curing oven at 122 degrees Fahrenheit. Air is circulated to cure the varnish in about 11 minutes. Bright lights also help cure the varnish. It's time to put the divisions in place. The hull liner has slots designed to receive the various wood components. Each part is fitted twice. First, to check the fit, then permanently with high-strength adhesive. It's time to install the engine. With its 54 horsepower, the boat can cruise at 8 knots, even when the wind isn't blowing. This stainless steel structure serves to reinforce the rudder. It's attached with epoxy glue. After closing the rudder mold, they insert a paper cone to completely fill the rudder with urethane foam. The foam expands as it cures. They finish by carefully sanding the edges of the rudder, which is now attached underneath the hull. To build the boat's deck, molds for the top and bottom parts must be aligned. High-strength bonding material is applied at specific spots. The two molds are carefully fitted together. When the parts are perfectly joined, the mold is removed. The deck is now ready to be fitted on the boat. Workers carefully line everything up. Luxury sailboats have enough space for many rooms and can be customized with appliances and electronics that suit the customer's needs and tastes. All that's needed now is a dip in the test pool for a check of the engine, generator, and other mechanical systems. After about 3 months of hard work, the boat is now ready to set sail for offshore adventures. What do the letters F, D, I, O, and U have in common? They are all part of postal codes, used in abbreviations for state names. These letters and numbers are read by high-tech machines that sort our mail. The trucks unload the containers picked up from postal outlets and bags of mail that were collected from public mailboxes. The containers go straight to automated sorting. Their contents have already been classified by size. Not so for the bags. Postal workers empty them and put standard size envelopes on a conveyor belt leading to one sorting machine, and large envelopes into a bin destined for another. The standard size letters travel to a high-speed, high-tech machine that checks for postage. Stamps contain an invisible fluorescent material that illuminates under ultraviolet light. The machine's UV sensor scans both sides of every envelope. No glow, no go. Letters with postage are canceled with a postmark so the stamps can't be reused. The postal mark contains the date, the state, and the sorting plant's postal code. Next stop, a machine called the multi-line optical character reader. An impressive piece of equipment that processes up to 30,000 letters per hour. It reads and digitally photographs each destination address, matching it to the computer's address database. Then it prints the postal code in barcode format on the front of the envelope. A scanner now reads the barcodes and does a preliminary sorting. Local and regional mail stays here and moves on to the next sorting machine for a more detailed breakdown. Letters addressed to other regions go to the postal plants there, where a thorough sorting will take place. But what happens when all this sophisticated technology just can't make out the address due to, say, sloppy handwriting or smudged ink? The optical character reader machine puts the letter on hold and sends the address photo to the video encoding system. A postal worker deciphers the writing and types in the postal code, sending the letter back into the sorting system. Now, the local and regional mail goes through what's called the BCS, the barcode sorter. This performs a more detailed sorting by postal route. The machine scans the barcodes at a rate of 30,000 letters per hour, sending the mail to the corresponding letter carrier's bin. A worker preps the mail for each route, grouping and labeling it by sector. Meanwhile, the large envelopes go through what's called the flat sorting machine. It does what 3 machines did for the standard size letters. Postmarks the stamp, reads the address, applies a barcode sticker, reads the barcode, sorts the mail, and drops it into the corresponding letter carrier's bin. If the machine can't make out an address, the envelope goes for manual sorting. In manual sorting, postal workers handle more than just illegible addresses. They also hand sort mail going out of country and envelopes that are too thick or bulky to go through the automated machines. At all stages of mail processing and delivery, workers are on the lookout for envelopes bearing insufficient postage. Those letters are returned to sender. Letter carriers sort the mail for their routes by street and house number. If they have a walking route, they load up their first bag full and head off. A truck delivers the rest to a locked box along the route, called a relay box. Carriers pick up the rest of their mail when they pass by it. Some letter carriers have what's called a motorized route. They deliver all their customers' mail by truck, which sure beats walking door to door in a blizzard. Have you ever dined on fungus? Well, if you've eaten mushrooms, you have. We like to think of those tasty little umbrella-shaped things as vegetables, but technically they're fungi. Fungus omelet, anyone? Mushrooms grow in compost, and preparing that compost is a science in itself. It starts with horse manure and straw. The correct balance of moisture and air is critical because mushrooms need both to grow. So mushroom farmers have to turn the pile frequently to air it out. And they water it daily for about a week. This kicks off plenty of chemical and biological activity. Ammonia forms, and microorganisms grow and reproduce, releasing heat. Good compost requires a nitrogen content of about 2%, so farmers add a nitrogen supplement. Chicken manure. They also add gypsum, a mineral that improves the structure of the compost and neutralizes its acidity. At the week to 2 week mark, depending on how the compost is progressing, it goes into the composter, which waters, aerates, and blends it. The compost comes out chocolate brown, smelling of ammonia. Next, they pasteurize it to kill off any insects or insect eggs. They heat the compost at 136 degrees for 8 hours, then at 113 degrees for 5 days. Then, over several more days, they gradually cool it to 77 degrees as microorganisms turn the ammonia into a nitrogen protein, a mushroom nutrient. The compost is finally ready. The farmer sows grains of wheat inoculated with mushroom mycelium, fine threads of fungi that act as the mushroom's roots. A layer of soil and peat moss goes on top of the compost. The mycelium draws water from the soil and nutrients from the compost. After about 2 weeks, tiny mushrooms begin to develop. They grow fast, doubling their size every 24 hours, and this in relative darkness. Green plants need sunlight for photosynthesis, but mushrooms don't. What mushrooms do need is air, because they breathe in oxygen and breathe out carbon dioxide. Green plants do the opposite. Another 3 days, and the tiny mushrooms are fully grown and ready for harvesting. Pickers have to be careful not to remove the roots, because left intact, they'll sprout a new batch of mushrooms every 3 to 5 days for about 3 weeks. They put the harvested mushrooms in a refrigerator, just above freezing temperature, for about a half hour to stop the growing process. On the packaging line, they weigh the mushrooms and arrange them in a container, buttons up. A machine perforates the plastic covering to let the mushrooms breathe. This ensures a longer shelf life. The mushrooms stay in a fridge until they leave for the store the following day. It's taken about 12 weeks from the start of composting to your supermarket shelf. For more than 1,700 years, the compass has been helping people find their way. It was first developed in China, but when the Far East met the Far West, European sailors adopted the technology, using it to chart their own courses. To make a nautical compass, they use this device to magnetize a special metal alloy. A technician slips a retainer ring onto a jig and positions the magnet on top of it. She places an aluminum skirt over the magnet. This will support the compass dial, which goes on next. She inserts a pivot needle in the center, which will allow the dial to rotate. Then she press fits all the pieces together. She carefully inspects the fit, and it looks solid. She sprays a chemical cleaner into the pivot cavity. It has to be spotless because any dirt would impede its function. She also cleans a little jewel post that contains a tiny sapphire. Then she fixes the jewel post in the dial. The jewel post will support the dial while allowing the pivot needle to move easily as it's pulled by magnetic forces. She places the dial on a machine that mimics the Earth's pull. It's a crucial step because magnetic force varies depending on where you are in the world. She brushes a weighted paint onto the back of the dial to counteract the pull. This balances the compass dial, preventing false readings due to differences in the planet's magnetic force. These are lubber lines, little direction markers. She inserts them into holes in a jig. Then she lines them up with holes in an aluminum gimbal pan and press fits the lubber lines to the pan. Now she inserts 2 pins into the gimbal ring that allow the ring to flip around the gimbal pan. Then she attaches the compass dial to the gimbal assembly. The technician spray paints the metal compass bowl black and pops a rubber diaphragm into it. A bronze ring will hold it in place. This flexible rubber liner will contain the compass fluid and allow it to expand and contract. She snaps the dial and gimbal setup to the bowl. She just has to bend a little tab to level it out. She positions an acrylic dome on top. Using another jig, she puts a rubber O-ring over the dome to seal it, followed by a metal collar. With a power screwdriver, she anchors these pieces to the rest of the compass. Then she pumps fluid into the bowl, filling it right up to the dome. The fluid makes the numbers on the dial look bigger. Next, they magnetically charge 2 metal rods and install them in a compass base. They'll compensate for magnetic fields on the boat. She mounts a big metal housing unit on the base. Then she attaches shock absorbers to cushion the compass against engine vibrations. She installs the compass in the housing and taps the dome to test the shocks. A decorative aluminum cover fits around the dome. Then she installs a light to allow the navigator to see at night. She attaches iron spheres, another tactic to counter magnetic interference. Our journey through the plant is now over, and the compass is ready to be used. Scan the snack food aisle of your local supermarket, and you'll notice that barbecue, ketchup, and salt and vinegar are no longer limited to potato chips. Nuts come in tantalizing taste choices too. But if you're a traditionalist, you can still buy them plain, salted or unsalted. The botanical definition of a nut is a dry one-seed fruit in a hard shell that doesn't open on its own. Most peanuts have two seeds, so even though we call them nuts, they're technically a legume, a type of pea. One way to prepare peanuts for sale is to roast them whole, right in their shells. This is known as dry roasting because they cook the peanuts without using any oil in a large convection oven. The oven temperature is 300 degrees Fahrenheit. The roasting process takes about a half hour. When the peanuts come out, they're fully cooked and ready to be eaten. Before the peanuts go off to be packaged, a worker inspects them, removing any shell fragments and foreign matter. Another way to prepare peanuts or other nuts for sale is to dry roast only the seeds. These peanut seeds arrive at the factory with their shells and skins already removed. A conveyor transports them to a revolving drum called the tumbler. As the tumbler spins, the nuts are sprayed with a liquid seasoning mixture. One of 10 flavors this company produces: salted, smoked, ketchup, barbecue, and salt and vinegar, just to name a few. The rotating action ensures the seasoning coats the nuts thoroughly. Now a conveyor transports the peanuts to a convection oven. The conveyor turns from side to side, spreading the peanuts in a thin layer so that they'll dry roast evenly. They roast for the same length of time and at the same temperature as peanuts in the shell, about a half hour at 300 degrees Fahrenheit. As they exit the oven, a worker breaks up any clumps. When they use the other method of preparing shelled nuts, they tumble on the seasoning after cooking. Instead of dry roasting the nuts as we saw earlier, they fry them in oil. This process is called oil roasting. It gives the nuts a greasier, fried taste. These cashews are on their way to be oil roasted. They go into a huge frying tank containing 580 gallons of canola oil, heated to 320 degrees Fahrenheit. The nuts come out fully cooked 15 minutes later, and they're steaming hot. A powerful ventilation system draws the heat outdoors, cooling the cashews to room temperature. This process takes about 15 minutes. By now, the nuts have absorbed any cooking oil that remained on their surface, so they receive a light spray of vegetable oil. This makes their surface sticky again, so that the salt or seasoning mix will adhere. This factory also produces nut mixes. Here, the mixer is combining various nuts with dried fruit. From there, it's onto a packaging machine, whose 8 computer-programmed scales automatically weigh out a specific package portion. But before each portion goes into a bag, it passes through a metal detector. This ensures that no shards of metal have worn off the equipment and fallen into the food. The machinery hermetically seals the plastic packages. This keeps the contents fresh for at least 6 months. Used oil furnaces generate heat by burning used oil without having to refine it. These furnaces are found in automobile shops, maintenance facilities, and construction sites. Transport fleets and trucking companies also use them to turn the used oil they produce into heat for their facilities. It takes a special furnace to burn used oil. Used oil is thick and dirty compared to residential fuel oil and must be turned into a fine mist to burn properly. It all starts with a computer-controlled laser, making what's called the front and rear flue plates out of steel. The plates for this hot air furnace are made of stainless or hot-rolled steel, depending on the size of the unit. A worker then makes what's known as the heat exchanger by joining the flue plates together with steel tubes called flue tubes. This device is called a swagger machine. It expands just the ends of the flue tubes, bonding them in place with the flue plate. Next, he assembles the section in which hot gases collect after passing through the flue tubes on their way out of the furnace. He then sets a combustion chamber on the top of the heat exchanger and welds them together. He completes the heat exchanger assembly by welding on a base equipped with 2 air deflector plates. These square plates help direct the ambient air as it enters the furnace and circulates around the combustion chamber. Meanwhile, an electrostatic powder coating machine paints the outside covers for the furnace. Next, they put on inner air deflectors, then assemble the cabinet. They bolt everything in place, then put on an insulated door. Now he hooks up a blower control box. This electrical box regulates when hot air is sent into a room. A worker then connects a tester box to the temperature controls that measure the temperature inside the furnace. He runs a number of tests to confirm that both the blower and the burner will turn on or off when they're supposed to. He verifies the operation of the door that allows for cleaning out ash residue. A technician installs a 100-watt pencil heater inside a brass nozzle adapter, then threads a thermostat into it. This nozzle adapter heats the oil and turns it into a fine mist so it burns properly. She then attaches assembly fittings to the adapter so she can later mount it inside a burner housing. She checks these fittings with a leveling tool to ensure the adapter will go on straight inside the housing. She also installs an assembly that controls oil flow, temperature, and air pressure. Then she mounts the nozzle adapter and covers it with a retention head that shapes the flame for optimal heat, completing the burner assembly. A worker then hooks up the used oil and compressed air lines to begin testing the burner. He turns on the oil, ignites the burner, and looks through an observation port to verify the burner is working properly. A closer look shows the flame is at the right intensity for optimal heat with minimal emissions. The furnace is now ready to turn used oil into useful heat. Artists first used flexible metal containers for their paints back in 1841. Nowadays, we use them for a range of things, like toothpaste, glue, and skin cream. The tube's design lets us squeeze out most of the product, and yet still read that important fine print on the twisted package. These packaging tubes are made of aluminum because it's affordable, lightweight, and malleable. This company makes each tube from an aluminum slug about the size of a coin. A worker dumps a batch of slugs in a container, then adds a lubricating powder called zinc stearate. The container spins, causing the powder to coat the slugs evenly and prep the metal for stretching later on. The slugs then spin around in another container which orients them horizontally, so they'll fit through a channel at the bottom. The channel feeds the slugs into a forming press. In a process called impact extrusion, each slug moves onto a die, which gives it the exterior shape of a tube, including the neck. At the same time, a mandrel forms the interior. This process hardens the metal, something they'll correct later on by heating it. The machine applies 200 tons of pressure to as many as 150 slugs per minute. They can be as narrow as a ½ inch and as long as 8½ inches. This machine uses compressed air to align the tubes for the next step. A trimming machine cuts threads into the necks by passing each one between two synchronized rollers. Stationary blades trim the top of the neck, making the surface smooth and safe to handle. The neck on most models remains sealed until the consumer pierces it. Another company eventually seals the tube by rolling up the other end after they've inserted their product. After heating them to soften the metal, the tubes move through another machine. Here, nozzles spray the inside with 2 coats of epoxy lacquer. This creates a protective barrier between the aluminum and the eventual contents. Rollers apply a coat of polyester enamel paint, which is flexible when dry and resistant to most solvents and sun damage. Grippers place the tubes on long pins, which move them through an oven for 7 minutes so the paint can dry. From there, it's off to the printing machine. Each tube makes 1 complete rotation against a printing plate. The plate applies a colored image and information that describes the tube's contents. Then they go back in the oven to dry the ink. The printing's legible even when twisted because the polyester ink remains flexible. Another machine applies 2.2 pounds of torque to screw on the plastic caps. Most of the caps have pointy tops used to pierce the sealed neck of the tube. They use flat caps to close off tubes with open necks. On the next machine, nozzles spray on a strip of latex sealant inside the open end of the tube. The latex is like a gasket. After the product is inserted, it seals the tube when they fold the end over. After a machine packs boxes with an average of 300 tubes each, a worker inspects the inside of every tube. A bright spotlight reveals any chip in the paint that makes the packaging deficient. About 1 in every 500 tubes is flawed. A sheet of sticky paper over the open ends of the tubes keeps them from twisting during shipping. And a label on the box provides tracking information and a way to show if someone has tampered with it en route. Empty. Each tube sells for about 12 cents each, a great bargain for such a useful item.